This video is called Factors and Prime Factorization. Let's start by defining a few terms. Prime number. Prime number is a number that has factors of only one in itself. So for instance, 2. 1 times 2 equals 2. There really are no other options. If I take the number 3, which is also prime, 1 times 3 gives me 3. 5 is another prime number. 1 times 5 equals 5. You can also think of it as a series of rectangles. Here's a rectangle that's 1 by 2 with an area of 2. Here's a rectangle of 1 by 3 with an area of 3. And I could also have a rectangle of 1 by 5 with an area of 5. These are all considered prime numbers. 2, 3, 5, 7, 11, and so on. Composite numbers, on the other hand, are numbers that have more factors than just one in themselves. So let's take the number 4. Well, I can get 4 by taking 1 times 4, but I can also use the factors 2 times 2. So I can make a rectangle with an area of 1 by 4, or 4, but I can also make one that's 2 by 2. So the factors of 4 include 1, 4, and 2, and 2. Another example would be 6. 1, 6, 2, and 3. This would also be considered a composite number. I can make a rectangle that is 1 by 6, but I can also make one that's 2 by 3. So composite numbers have more factors than just one in themselves, and prime numbers have only one in themselves as factors. Now a factor tree is where you factor out a number. So let's say we take the number 8. Well, 2 goes into 8. I'm going to circle 2 because it's prime 4 times. 4 isn't prime, so I'm not going to circle it. I can factor that number out farther. It's 2 times 2. Both of these are prime. So now I have completely factored out 8. And its prime factorization, 8's prime factorization is 2 to the 3rd power. Let's look at another example. Let's say I take the number 6. 2 times 3, both prime numbers. So the prime factorization for 6 is 2 times 3. What about 18? Well, I have 2 and 9. 9 isn't prime. 3 and 3. So the prime factorization of 18 is 2 times 3 to the 2nd. Now let's think about what we call a perfect square. Notice how 4 has a factor of 2 in itself. And actually, when I draw the area, it forms a square. So 4 would be considered a perfect square. Another one would be 9. 3 by 3. Another one would be 16, which is 4 by 4. See if you can guess what the next square or perfect square would be. Finally, let's look at what a monomial is. A monomial is a number, a variable, or the product of a number and one or more variables raised to the whole number powers. So here's an example. If I take the number 32 times b to the 5th, c to the 4th, this would be considered a monomial. It has a number, a variable, the product of a number or one or more variables, and they're raised to whole number powers. These are considered monomial. Now let's practice writing all the factors of a number. To write the factors of a number, we make a tree. This is different than a prime factor tree. Well, I know that 1 and 44 work. 2 goes into 44 22 times. 3, does 3 go into 44? No, so I'm not going to list 3. 4 goes into 44 11 times. 5 does not, 6 does not, 7, 8, and so on do not. So these are the factors of 44. 1, 2, 4, 11, 22, and 44. You will notice under the Handouts tab of your OneNote notebook, you have a Divisibility Rules tab. This tells you quick and easy ways to determine whether a number is divisible by 2, 3, 4, 5, 6, and so on, all the way up to 100. So this is a great resource under your Handouts tab and will help you find all the factors of a number. Let's do number 65. Again, I'm going to make a factor t. 1 and 65 work. Now if I use my divisibility rules, it doesn't end in an even number, so 2 won't work. If I add 6 and 5, I get 11. That means 3 won't work. 4 won't work. But 5 works because it ends in 5. 5 goes into there 13 times. And then the rest of the numbers don't work. So my factors are 1, 5, 13, and 65. Here's the number 127. Tell whether the number is prime or composite. All right, well, let's make a factor t. 1 works, and 127 works. 2 won't work. 1 and 2 is 3. Well, 7 is 10, so 3 won't work. 4 won't work because 2 didn't work. 5 won't work because it doesn't end in a 5. If 2 and 3 don't work, 6 doesn't work. Let's try 7. 7 goes into 12 once. That leaves me with 57, which is not divisible by 7, so 7 does not work. 8, 2 and 4 would have to work, and they don't, so 8 doesn't work. 9 doesn't work because 3 doesn't work. 10 won't work because it doesn't end in 0. And 11 and 12 don't work. So, yes, it's prime. Let's look at the number 133. Is this number prime or composite? Well, we know 1 and 33 work. 2 won't. 1 plus 3 is 4, plus 3 is 7, so 3 doesn't work. 4, 5, 6 doesn't work. Let's try 7. So if I have 133 divided by 7, 7 goes into here once. I get 63. Okay, it goes into there 9 times, 63. So 7 times 19. That means that it has more than 1 in itself, So this number is composite. Let's make a factor tree. Then write the prime factorization of the number. All right? So we're going to start with 2. It's prime, so I circle it. And 180. 2 times 180 gives me 360. Let's try 2 again. Goes into there 90 times. 90 is not prime. 2 goes in again 45 times. Okay, now 2 won't go into this, but 3 will, because 4 plus 5 is 9. 3 goes into 9, so 3 will go into 45. It goes into there 15 times. 15 isn't prime, so I need to keep factoring. Goes into there 3 by 5. Both of these are prime. So now I have my factorization of 360. I have 1, 2, 3 2s, so 2 to the third, times 2 3s, so 3 to the second, times 5. So this would be the prime factorization of 360. Now, here's where it gets a little interesting. Let's say I want to factor a monomial. All right? B and C are already factored out, b to the 5th and c to the 4th. So I'm going to just leave those. Now, I need to factor out the number 32. 2 goes into there 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 2 times. 1, 2, 3, 4, 5. So it's 2 to the 5th. So the prime factorization of 32 is 2 to the 5th. So 2 to the 5th times b to the 5th times c to the 4th would be that monomial factored out, the prime factorization of that monomial. Let's do one more. Now I have g to the 3rd and h. And I want to factor this one out. I just need to factor out 40, 2, 20, 2, 10, 2, 5. This gives me 2 to the 3rd times 5 for 40, 2 to the 3rd times 5 times g to the 3rd times h is the prime factorization of the monomial 40 g to the 3rd h. This is the end of the video on factors and prime factorization. When you're doing the homework, I would like you to make sure that when you factor numbers that you use the method I showed here. Start with 2 if it works, circle it, then don't repeat it. So don't continue carrying that 2 down like you've maybe learned in the past. You should have something that looks like this, and then your factorization. This is the end of the video.